and live on YouTube as well. Now, I actually set up like the overlay stuff, so I should get notifications for like the subs and whatnot. I'm wondering if the chat box doesn't work until I actually start streaming. So at YouTube, and we'll see if anything shows up. Nothing is showing up. So LLVM is a... Here, I can just bring up the page. LLVM. It's basically this toolkit for making compilers. So they have all sorts of pre-built optimization stuff and even like a JIT runtime. So basically the idea is you can just plug this into whatever custom grammar it is, and then you create the abstract syntax tree for that yourself, and then you feed it into this, and you can use any parts of their toolkit. It just makes it easier to make languages. Now, the point of this stream that I'm doing right now and what I hope to get done is I already have a scripting language that works all the way from code to actually running it. However, I want it to be more robust and be able to make it easier to add more stuff in the future. Technically, yes. I am currently at a college. Though I haven't gone to classes in a while, so... Alright, so... Getting right into it. I have this little Scratchpad project I put together yesterday where I was just testing out the actual LLVM library. So that's going pretty good. The engine is in a good place, and as soon as I get the scripting language working, I'll just be able to throw it in and we'll have 80% of a fully working game engine. So that's another reason why I'm ripping out my own stuff and throwing in LLVM, because then it's basically done after that. And any other features is mostly on the syntax side rather than me building out an entire optimizing compiler. But yeah. So I built out this test project to just test out how the library feels and whatnot. So if we run this, it takes a second to start up, and then we get the result. So this is the intermediate representation that LLVM creates. I just created a function that adds two doubles together and then adds them to a double constant. This is like the serialized version of the bytecode. I don't think it's actually this long. It's just like a bunch of line breaks and whatnot. And then I just checked to make sure I can deserialize that again into the intermediate representation, so we can then throw it back into LLVM and actually JIT the function and run it, which is the exact same thing that the scripting runtime I've been working on for like 6 months is able to do. So yeah. In less than 150 lines of code, I can do 70% of what I've been working on. But yeah, so we're basically just going to go through and yeah, throw all this together. Is there a way to check if these have already been done? I think I might just pull this off with a static variable. Okay. Let's do this. Oh, I don't want to do it on both windows. I only want to do it on that one. Ah, whatever. Alright, so the parts of the language that we're going to have to change is all in... Okay, so these didn't get deleted when I rolled back stuff. We don't need them though, because all of this was just me trying to make my own version of what we can just use LLVM for. So what we're going to be refactoring is the AOT nodes, and then I might refactor stuff to make this make more sense later. Because yeah, I'm not a fan of what they are right now. Because yeah, we don't need to worry about a lot of the stuff we used to worry about with these. In fact, another thing I want to do is just delete all of these nodes and then only use the document context stuff. And generate the AST with that instead of generating a AOT tree from the document context. And then after that, once again converting from a node tree into another node tree. So what I might do instead is make it so that we generate the actual thing, like the AST from the document context nodes, just through a recursive call. Yeah. So that's what we're going to target, is doing that. Okay, the question is, this data layout here, we want the JITted code to work on any machine. So we will need all of that to be like in the runtime, whatnot. So it's basically down here that we would want to when we get this serialized module, we would say deserialized module, set the data layout, like that. And then we wouldn't need this up there. So I'm just gonna check if that works real fast or if we need to in advance set data layouts. We shouldn't, since bytecode is supposed to be portable. Or the intermediate representation, it's not technically bytecode. It's a DAG of three argument operands, or operators. And this takes forever to compile. It's not even the compilation, it's just the linking. I even tried cutting down on the amount of libraries we use, but... Okay, cool, so we can set data layouts anytime we want, after creating functions and whatnot. So yeah, that was one thing I was worried about. Alright, first thing before we do anything, we actually need to import the LLVM libraries into the scripting language, which is going to be hard because I'm using Conan for the package manager, but they upgraded to Conan 2 recently, and a lot of the packages for Conan 1 don't work with Conan 2 anymore, so it's like, yeah. So like LLVM core 13 is available in the Conan package. Wow, I don't want to, there. It's available in the Conan packages, but I have to downgrade to Conan 2 to actually use it. And I already upgraded this package to Conan 2. No, downgrade to Conan 1. But I already upgraded this one to Conan 2. Which is a pain. So I might have to downgrade this just so my package manager works. Let's just try it. I already know it's not going to work because I tried it over here. So yeah, we throw in LLVM core and run CMake. Interesting. So maybe it's something with like the Conan profiles, Or, oh, wait a sec. No, it's because I downgraded Conan, so this is just working, but it won't actually build anymore because like all the targets aren't there anymore. So if I try to run this, it might not be able to link to things anymore. Or it will. So yeah, first part of the stream, redoing the build system. And before I forget, in here, here, I want to set this to 1.59. That way my CI actually works. And then I'm going to steal these two. And this. And that should be enough to break stuff to where I can then fix it again. Okay, and it didn't go through the whole installing process because I already have the LLVM on my machine. Got it. So now we just have to change back package names. I'm suspicious about it just working. So you're telling me it actually does find, well, that one actually didn't cause an error. It was Antler before that was causing the errors. I mean, if it works, it works. Let's try this. What did I do here? Oh. I might have to rewrite the caching part of the CI just because the download location will change. But I just want to see if the CI still works. It does not. Oh, it's because the Conan profile command. All right. So if I look at the history for this, let's look at the upgraded to Conan 2.0 commit. We can go into here and just kind of, just like that. The other main thing that changed was we don't need any of this stuff there. Okay, it's just the build type and output folder, like that. And just like that, our CI should be fixed. Let's amend this. Oh, why can't I force push? And this should fix our CI. Because that's the main, like, concern I have here. Alright, install and configure Conan runs on the CI, so we should be good there. Up and CMake breaks. Maybe I still need to pass the build missing flag. try this. Okay. So I'll just have to run the build missing command still. That's okay though. Okay. Alright, I'm not gonna worry about the CI for the rest. Oh, wait. Okay, we're good, yeah. It runs CMake, so. Moving on. So we now have LLVM imported into our project. And let's import everything, but we don't need the ASM parser. We just need those two, I believe, for the actual building. And this one depends on the target. We're not targeting... Oh, come on, Brane. We're not targeting anything from other than 86 yet, but we do want to target ARM in the future because, yeah, because Quest is on ARM. We want to support the possibility of Quest running this engine in the future. If we want the Quest JIT code. Maybe the Quest 3. The Quest 3 could probably run. Could probably run the engine. And scripting runtime. Not the Quest 2. Definitely not the Quest 1. Maybe, like, smaller apps. Okay, so... We're not worrying about the runtime yet. Right now we're only on the compiler side. We're gonna break some stuff before actually fixing it. So since I want to add in the ability for references, we're gonna have to do refactoring on the fly instead of replacing code. If I didn't want to do references as well, we could just literally replace my this is document context. I wanted AOT flow nodes. I could literally just replace all of these context append code with the associated LLVM command, and it would just work. It would just work. However, since we are not using my old system of just treating all pointers as structures, we can't do it that way anymore. Okay, I need to go to the bathroom. I'll be right back. Okay, so the overlay isn't working even though the stream element spot is in my chat. Interesting. Okay, so yeah, the CI has been configuring CMake for the last 6 minutes, which I assume means it's building LLVM. Which I am definitely going to have to start caching instead of having it build the entirety of LLVM every single time, because that would be mean. Right. So I'm going to add a virtual function to the statement context called create AST. And we're just going to forward declare this. And I believe it is a class, not a struct. So, and we're also going to throw a create AST on. Well, we have to throw it on everything, don't we? And we're also going to create an AST context to store variables to do with creating the AST. And putting that there means we will have to import some LLVM stuff. All right, so where are you from? LLVM context.h from IR. Okay. In compiler, we want to link Q2. Because I believe they have dependencies on everything we need. We won't need to link LLVM core manually, hopefully. Oh wait, I need to throw a find package in there, don't I? And regenerate that. Oh joy, are we building LLVM now? It looks like we are, so we didn't just cache it. Dang it. Well, do the include files at least work now? They do not. We're gonna have to wait for the entire build of LLVM to finish. So how have your days been? Oh, I do not have anybody watching. I shall sit here and silence myself then. It appears that my roommate is streaming as well. Let's pick on him, shall we? No bullying. Okay, let's... Let's break that immediately. We must judge his responsiveness to chat. He is dialed in. But yeah, if you want to get a sneak peek at kind of what the games we're going to start working on once I get like the scripting language working and the engine working as well, my roommate Alex is actually working on the 3D models for that at this very moment. But yeah, it's been working on the gun for one of the enemies, and it's been coming together pretty well. Is he playing music as well? He is.
Hey man, it's your game too.
I know. You know, I'd have to agree, Alex is a cool name. Then again, I feel like you might be biased. But yeah, right now we're just waiting for LLVM to compile, so I'm just stream sniping at the moment. Oh no, we have lost the page. Come back. Oh, no reason. I just get that vibe. You know, it's hard to get vibe through text, but I am getting that vibe. I don't think this is getting built multi-threaded. Because OBS is only reporting like 10% CPU usage. Well, it's halfway done. And then hopefully we won't have to do it again. Though it should have just used like the common cache between like this project and this project. Because I've already done this. Systems programming. I'm not quite sure what systems programming kind of entails, but my learning journey, like just how I got to this point, it wasn't planned out. Is basically I found projects interesting, so I just dove in and did them. So like I started out like, we'll just say when I started doing like VR stuff, I started out on WebXR because the only way for me to actually do VR was with like a Google Cardboard, and the easiest way to deploy it was over the web to my phone. So I just learned like a decent amount of JavaScript and web stuff to be able to do that. Played around with like NPM servers for hosting it locally and whatnot. And then I moved on to learning Unity just because like I felt like learning Unity, got really into physics stuff. So my best advice for learning programming would be to find projects that you would enjoy, and no matter how hard they seem, just dive right in, trial by fire, learn how to do it. That's what I did. And it takes a long time, but I don't know, it's what works for me. Alright, 65%. Ooh, I know what we can do. While we're waiting for this to compile, we'll play one of the best games ever to exist. Minesweeper. I mean, you might not want to jump directly to an operating system. But I mean, you could. There was one time where like I almost got started writing my own Raspberry Pi operating system. I got as far as getting the LED to blink, I think. But it was like a tutorial in assembly, so it wasn't really that sustainable. So I gave up after a little bit. But if you found like a way to do that in C, I would totally say like get a simpler device like a Raspberry Pi. Don't just like jump straight to x86 or whatever. But yeah, jump right in and try it if that's what you want to do. So let's see, 75%. Can we complete this before the compiler? That is the question. I am honestly not that great at it. Just done it for fun. I'm not sure which one this is. Come back to it later. Okay, yeah, definitely that one. Okay. All right, 80%. Let's see if we can beat this. That's a 3. Oh, that 2 is already, okay. That takes care of that corner. Takes care of that too. Okay, I'm not sure what to do there. Got a 3. So it's like here or here, I think. Or it could be here and then one there. Though given this 2 here, we can pull one of those. Definitely one there. Not one there. We might actually beat the compiler. Alright, let's see about this. We got 2 already. Oh, has to be all of those, which doesn't help me at all. Got so many. Wait a second. There we go. I didn't see that before. Has to be one there. Already got 3. Already got 4. It has to be there. There we go. We beat the compiler. Let's see if we can do an 8x8 right before this finishes. Oh, that's empty space. Okay. Let's see. Has to be one there, and since it's 4, has to be one there. This is true, but I already did that earlier in the stream, so I mean, I appreciate it being that thoughtful, but it doesn't help out much. See, if we had one there and there, that works. But I was wrong. That's a lot of ones. Which I like. Ones are amazing. One there, and one there. That doesn't... A 2 over here would be nice, because that would give me more hints. You know, it's here or here. It's probably here. I was wrong. For some reason, the harder difficulties are sometimes easier because you have more context about what's going on. And like, if one place has like 2 different possibilities, you can just solve it from a different direction. Oh, joy. Oh, that's fun. Oh, come on. I can't solve this. We guess. So 1, 2, 3, 4, 5. So one of these is not a bomb. And we have no way to guess which one of these is the not bomb. We're going with that one. I was wrong. Alright, let's see if we can get this one before the compiler. It's a quick race. Has to be there. Has to be there. Oop, there we go. Oh wait, did I beat it? Okay, no, it's okay. I did beat it. So we got 2 minesweepers done. Several almost done. So debug coverage failed, but debug... Is it building a different one for both of the... All right. How do we... Okay. How do we set the cache location? Okay, so it's literally a system. Wait a second, is this going faster? Is it just checking if it's built? No, it's still taking a while. Okay, so this is being put in there. It's whichever compiler Conan uses. Because basically what's going on is we're running this command to download our Conan packages, and one of those packages is LLVM, which doesn't ship as a binary, so it's needing to build it from source. So it's whatever Conan is detecting, which I think, if I were to scroll up to the top of this, it shows our compiler is libcxx. So I think that's just setting the version of the standard library we're using, though. Ah, there it is, compiler GCC. There might be a way to set this to be threaded instead. No, I don't want. Okay, good, this isn't. So apparently the command line arc can just be like that. But this is working, so we're going to keep it. Okay, can I just... What is a Conan file.py? So I'll just bring this over here, so we have it on stream. Yeah, I know you have Conan 2.0, but half the packages don't work, so I can't use it yet. So I can set the generator to something else, but it doesn't look like I can set actual arguments for it. So I just have to wait for this to build. Yeah, with Conan 2.0 and everything kind of breaking everything, I might switch off of Conan. Just something like a VC package or whatnot. Because I don't want to have to deal with this. Even though VC package still builds stuff, but at least then the cache would be shared between the two. Maybe because the build missing. Okay, yeah, it's not building everything. It's only building LLVM, so it's just not caching it correctly. But all of these should be building to the same place. For now, we'll just deal with it. Did this at least run? Nope, this is doing the exact same thing, still running. I might just have to include the built version of LLVM in the project or something like that. I don't know. Because I don't want it to completely wreck my CI and everything. Or I'll actually get Package Manager to actually, would a different revision of this have binaries? I'm gonna check to see if I already cache stuff. So yeah, we load the Conan cache, which is okay, good. So hopefully my CI just caches LLVM and never builds it again if it actually ever finishes building it. But yeah, time for more Minesweeper. It's because apparently the package, like Conan, doesn't have a binary version of it, so it has to build it from source. So basically, the package manager I'm currently using doesn't have a binary version of it, which sucks. And might be reason enough to switch off to a different package manager. I did not expect most of my stream to be taken up by me just compiling stuff. Because, like, once we get LLVM into the project, the refactors are actually going to go pretty quickly. Just because, with how much time I've spent building stuff from scratch, it makes sense. I just need to be able to use it. Compiling is cool, you know. You get the hacker feel to it. We can just, there we go. Right now I'm on Linux, but I also work on Windows a fair amount as well. It's just a dual boot. Ubuntu for if you want to know the exact distribution, because, you know, I'm a Linux user. I have to be like, I have to brag about the exact distribution, though Ubuntu is pretty standard, so it's not really a bragging OS. Back when I used Arch, that was a bragging OS. Oops. Literally 4 squares to go. You had me distracted, had me talking. See, what this means is that the other side over here is going to be chock full of all of the bombs. CMake generate stepped. Build files cannot be... Oh, joy. Okay, good. It is in my files, not theirs. Brane Script LSP server. Wait, LSP server? Did I accident? This was where I was probably talking earlier and threw that in. Okay. This should actually compile. There we go. We can actually start working on the refactors now. After what, 30 minutes of sitting here? Did I exit out of the Minesweeper? Dang it. Oh well. No finishing Minesweeper for me. Back to actually building stuff. So we should have the other include files now. Yes, we do. Alright. Back to this. So we want the LLVM context. What other ones do we want? So this is the H file, we want to keep it to a minimum. Types? No. I might be able to delete this now. Okay, it's not finding the other side of it. So... module. This is probably what... even though we don't technically need to include module in here. Okay, module is what defines value. Well, value.h is what, yeah. Okay, so where did I put it? Alright, so here's where we're going to create the AST context for actually creating the abstract syntax tree from our jank syntax tree. Our very abstract syntax tree. Okay, so we're going to need an IR builder for sure. Now, do I want to have this be a pointer to an external context? I do want this to be a pointer to an external context. That way we only need to initialize one and we can just keep reusing it. And then the builder, let's have the builder be specific to the context. That means we're going to have to create a constructor for this. And pass in the LLVM context to the constructor so we can actually create this later. Okay, so it's just called IR builder. Why is it complaining? Oh, right, because template arguments has this weird thing where, like, you use the default template arguments, but you still have to define it as a template for it to work. And we're gonna create the LLVM module. So this is going to be containing our script intermediate representation. And we're going to store it as a pointer, unique pointer, since that's what the rest of LLVM uses to pass stuff. Okay, it's already forward declared. Yeah. We're just going to have that as a unique pointer in there. Next up, we're going to want a map of named values. I might actually... So we're going to pull a funny here. And throw scopes into the mix, because while on the intermediate representation we won't actually have scopes, we do actually need scopes, or a way to define them. So we're going to go list, which is basically a stack. And in here, we'll have Robin Hood owner map of STD string to LLVM value. And we'll also have a list to global values. And I think module... No, wait. We don't need to store every single constant because the bytecode just... The optimizations take care of that. So we don't need to worry about constants. We'll just generate them using the API when we need them. No, I'm not going to mark it explicit so that we avoid unintentional casting because I do not care. Put this right here above. So we're going to set LLVM context to LLVM context. And after that, we're going to initialize builder with the LLVM context. And we're also going to create the module. So module. No, I don't want to make error code. There we go. Ooh. Let's add it to the constructor just... Yeah. Module source and the LLVM context. So there we go. We now have a module to start. Oh. to start generating stuff into. And that's literally all we need before we start to generate stuff. So now we move on to actually generating the bytecode, which is the fun part that it took us far too long to get to. How long has this stream been up? Two hours? Yeah. It says 1 hour and 30 minutes or something like that. One hour and 26 minutes. All right. So now we get to do the fun. I do not look forward to getting casting working though. This is true. All right, so let's just start at script context and work our way up. So, AST context, context. So starting at the actual script context, this is where we're going to want to actually call the function from to get a viable AST. Gonna change this to override. All right. Come on, Sea Lion. It's not that hard. Just create the function definition. All right, we manually create the function definition. There we go. So for the actual script part of this, what do we want to do? In what order do we want to do this? So looking at script context, we have global values, structures, functions, and other libraries that we, well actually, exports is more code as well. So what we want to do call order gets set, so we'll iterate over functions in the order of call order. And this includes stuff in, yeah. So we want to iterate over all of our data types and all of our global variables to generate definitions, I think. To structure definitions, do I see the actual padding is controlled by struct def. Ooh, so I need a way to handle types. How do I want to handle this? So in AST context, yeah. So let's make it a unique pointer. Actually, this might be a class. And in here, in actual struct def, do I have a boolean for? I do not. Well, I don't want to put it there. So let's create a structure. Let's not call it struct definition. Let's just call it struct entry. So we have our definition and bool is exported. So the reason we're doing this is because some structures are in libraries and we actually want to pass that along down the chain. So later down the line in my entity component system, I can actually use these struct definitions to use the structs in there. The structs that are created at compile time, and just use them like native structures in the entity component system. So we need to pass exported structs, like the ones we would be using as components, down the line. So let's pass this right into there. I won't worry about it for now. There's an easy way. I'm just worrying about us accidentally re-exporting structs from external libraries. Well, other modules than this one. Basically, we only want to export local exported structs, not... Because right now my idea is to regenerate struct definitions. For every single AST context generation instead of reusing them. So this value context, yeah, here, it's actually in type context. We store a pointer to the struct context, actually, to reduce that. We're just going to rename that to struct context. Okay. Sorry, Discord ping I wanted to take care of. All right. I am back. But yeah, so we store a pointer to the struct context if this type is a struct. However, this struct context might not be part of the actual current script that we're compiling. It might be a struct from a different script. And if that script is also exported, we don't want to export it. We don't want to double export it. So it's in defined in multiple scripts. It won't affect AST generation whatsoever. It's just it's additional context information I'm going to be passing along. There's an easy fix for that though. I'm going to create a function for this. Where do I want to put it? Under here. Const struct def pointer. Get definition for, and we're going to pass in a struct context here. And what this function is going to do is pretty simple. We're going to get the full ID of this struct, so that's everything containing namespaces, and if we already define this, so if we can find it in define structs, if defined struct is not equal to defined structs.end, return defined struct second dot is export, no, def dot get. So that returns structs that we have already defined. If we have not defined a struct, however, we are going to copy over this visit struct function here. And we're going to include struct definition. Struct context and we're just gonna pull a quick get constant type def, get type const type context let's forward declare it up here. And this is going to do a very similar thing. However, it's going to take into account that we do have some native types. So if type context does not have a defined struct context, actually, we can make it even easier than this. We just use that, get definition, type context, dot struct def, or struct context. So then that will do its thing getting the structure context, and I do realize we now have a loop between these two, but it should never loop between the same type. It should just like get all the dependencies of a type. However, if you have a circular type dependency, that's bad. However, we should have things in place to check to see if we have circular type dependencies. So it is something that should have been error checked beforehand, so we shouldn't technically need to worry about it. And then we can just call get native type def, which is stored in native types. There we go, and we can just throw in type context storage type. and we're going to assert that the type context storage type is not equal to value type void and struct. And then we will return the native type def for that. So in here, we just say get type m type. And we'll reference it. And that will create our struct definitions on demand. So I actually don't need to iterate over everything, since everything is already kind of linked together by the document context. The one thing I do have to worry about, though, is defining global variables. So I think we have to manually iterate over those. So let me quickly consult the documentation. Mutable variables. So actually, I'll pull this over here so everybody can see it. I'm just looking at like the kaleidoscope tutorials, just because that's basically all I need. So they're saying, except instead of being declared with global variable definitions, so it's probably not going to show me the oh wait, we do have globals here. Okay, so where do I actually define them? I know about the LLVM alloc thing. Is this all I get? Maybe it's in an earlier tutorial. I know it's not in the JIT thing. Maybe it's just, okay. Oh, so all these are aired out because they don't have the function. Nothing's actually broken for once. So in here, I'm just gonna check context builder and see if there's a method that's just conveniently called there's not. Create, no. Okay. This is the same tutorial. Oh. Let's see if this links to... Is there an also see function? Or not function, section. Oh, this is all of them. Okay. String. Ah, look at that. There's a whole section here. So lang reference might be what I want to look at for all of this. So is it define? Come on, help me out here. Oh wait, I'm dumb. It's not the builder that you use to actually write the code, it's the basic block, so... Because yeah, over here... Wait, but no, it's the... Wait... Is it the module? It makes sense for it to be the module. So I can get or insert global. This is what I want. So this is how we insert globals. Good to know. Anyway, I will be right back. Alright. I have returned. So yeah, what we want to do first is register all of the globals. And the way that we're going to do that is by iterating over all of them. For auto G in globals, and then we're going to do context module globals. And is get or insert global the only one? That's interesting, and it returns as a constant. I mean, that makes sense since it's a constant memory location. But that's really interesting. That's interesting. We have a callback we can throw in for creating globals. Don't know why I would need to. G dot identifier. And we shouldn't need to worry about do I need to worry about it spelling? I'm not for now, but that's something I want to test in the future. Is if this module is actually no, since it's a constant memory location, it would be part of this module and have constant references to it and just completely lose the name. And the name is debugging only, so I think when loading this into the JIT compiler, it won't. We'll find out. And then the type. Okay. Ooh, we need to get... do a get LLVM type, and into this we pass a type def. And this one should only need to be constant. So let's for once solve the get LLVM type. Here. That's right, it would be the next one. Okay, so it's under the LLVM type. So switch on type def type. I did the capitalization on this weird, and I actually think I want a type context here. Instead, because the type context actually gives me like stuff. So if this has a struct context, we'll do struct stuff. Otherwise, let's see, no void, no struct. We want this to default to a throw, not an assert, since we want this to happen at runtime as well. Invalid type requested, and we're just going to leave it at that. And in here, we'll do the LLVM type get double type. Oh, there's differences for pointer versus. I do want to take that into account. So we actually don't need this to be a type context. We need this to be a value context. Because value context has this nifty little field called Actually, I want to rename that as well. So this isn't type def, this is value context. But yeah. Value context is ref here, and ref is what it's what I call pointers in my language, and I'm kind of doing like the C# thing where you hide them a little bit. Behind the scenes. So here we want type and there we want struct context. Here we'll pass the LLVM context for those two types. Oh, get double pointer type. Look at that, we're handling pointers. I'm so proud of myself. We don't want float begin, we want... It always does this. Okay, so here for float we want get float. Oh. Oh, we do have a float pointer type, okay. What is a B float? Is that binary float? No results on Google. Oh. TY. There we go. Get B float. $16-bit Brane floating point value. What is a Brane floating point value? I have never heard this term in my life. The bfloat16 or Brane floating point format is a computer number format occupying 16 bits in computer memory. It represents a lot. Okay, but what? Is it just like a half precision float? All right, let's see what Google Cloud has to say. Brane floating point. The dynamic range of bfloat16 and float32 are equivalent, however, it takes up half the memory space. Interesting. Okay, so it's still like... Does it still use like IMM registers and all that? I'm not gonna worry about it for now. I'm just like... What is a Brane... Oh. Float. Oh, it's a Google specific thing. That's why I'm not getting very many results on it. Originates from the Google Brain Artificial Intelligence Research Group. Okay, so this is something like super obscure I don't really need to worry about unless I want to add a language learning module into the server side of my servers directly, which at the moment I don't plan on doing. It would be cool to have AI stuff eventually, but I'm going to do it through APIs and not just directly embedding it in the server. Alright, so we're just going to do get float type. Apparently since it's half the size, it just runs better on Google's TPU. So basically, yeah. So it's, yeah. D is a common method used to decrease time conversions without losing accuracy. So TPUs, so I think they're basically fancy graphics card. So yeah, a tensor processing unit. So it's essentially a AI specific graphics card, and this is just the data type they use because when you're working with that level of scale of data where you just need as much throughput as possible, I guess every little bit of memory counts. So somehow they're getting the same amount of they're claiming that the range of the thing, see like here, 1 with the e to the power of negative 38 to 3e to the power of 38 is the range of this float, and it's the exact same as like a regular 32 point precision floating point somehow. So it's just a TPU specific data type that is somehow black magic better than regular floats in every single way. But I'm not going to worry about that for now, for just just the scripting language. So get int 64 pointer type, get int 64 type. This is just the LLVM supports literally everything under the sun, and that is one of the things under the sun. Actually, we're going to copy this one for that, and then we're just going to add a U in here. Oh, come on. It's not that easy. Do I have to say unsigned? I don't. Get... I know that they have different for types for unsigned, because it's reflected in the bytecode. I mean, the registers you use are the same, so maybe it's just that. I'm not sure, though. Okay. Oh wait, that's the pointer types. So not that. See, LLVM define unsigned int. Oh, that's interesting. I thought they did make a distinction. I guess I was wrong. So this is exactly the same as this. And we just don't need to worry about it. And then I know that these two are the same. So basically, I will have to account for signed myself when calling signed versus unsigned math stuff mostly. So get int 8. So yeah, when you're dealing with computer registers, you use the same exact registers for both signed and unsigned, and then it's the actual operands you use on the data that changes it. So if we were to look at my scripting runtime, wherever I put it, there it is. Script runtime, so if I find something like multiply, so you can see right here, depending on the value type, I use, so for unsigned, I just use mul, but for signed, I use integer multiplication, or for some reason I is signed, or immediate, because it handles multiplication different for signed and unsigned, since this has no concept of, well, this has no concept of negative values, so the upper half of the register is obviously, you know, handled differently. But yeah, and it was super fun figuring that out, because you see right here, multiplication actually, when you're doing the assembly by hand, it takes 2 registers in for the left side, the thing getting multiplied. So the result is stored in these registers as well, and then they're multiplied by this register. So if both registers you're going to multiply are both like 32-bit sized, you actually need like a full 64-bit register right here, or 2 registers together that fill up to like that go together to make a 64-bit one, because in assembly language, like, they want to preserve the data instead of overflowing it. So basically I have to do a sign extension on the data itself. So if it's a negative number, that upper register is in all zeros, it needs to be all ones if it's negative. So it takes 2 operands to do the multiplication. And luckily, LLVM is going to take care of all that weirdness for me, so I'm just not going to have to worry about it anymore. But yeah, same stuff here with like the XORs and whatnot. I look forward not to have to worry about this again. Yeah, I'm pretty sure I'll just pass in the two values to the multiplication command. So actually, we can play around with this right here. So this is how I create the intermediate representation. So for a float addition operation, say create f_add, and then you pass in the two arguments. And there's no difference between booleans, not booleans, doubles and floats. I think it just automatically detects the correct type. It just expects the two to be the same type. So you actually do have to cast before passing it in there. But let's see, create u. So yeah, so there's our unsigned division, and then there's our signed division. So S for signed, U for unsigned. But I don't have to do signed extension beforehand, I hope. The LLVM optimization should take care of all of that. I sincerely hope. Actually, going back here, create unsigned div. Okay, yeah. See, we have our left-hand side value, our right-hand side value, and then just the debug name. I don't have to worry about sign extensions on multiplications and divisions. We good. I just have to worry about the sign and keeping track of that myself. Other than that, we are good. So yeah, now we just have to worry about how to deal with struct types. LLVM type, and then let's do some shopping. Is it called an aggregate type? Oh, that's cool. I can check if stuff is pointer or not. That's nice. No, I don't want to create a global pointer. I think a global pointer is easy. I just pass in the pointer type. I'm on the West Coast at the moment. Define, we'll just say define struct type for now, because I feel like I just used the pointer version. Define struct type. Now I wanted to get away with just not defining the structs in LLVM. Because I just wanted to like treat them normally as I do here, because I already have all the logic for dealing with structs. Oh joy, so I do have to define them. and deal with possible alignment issues. Is there a way to set alignments manually? Alright, thanks for sticking around though. Alright, I'll just have to deal with the is packed bool and hope it's good for now. This is a good reason why we have struct entry. So LLVM type. Yeah, no problem. I'm just glad it's actually getting interesting now. So instead of, oh, that's what I could do. We just define the LLVM version of it first. Oh, I forgot to add this to the defined struct list. That's a pretty big oops. There we go. Oh, there we go. So let's create the LLVM version of this struct first. I think we can just LLVM, let's see, entry dot LLVM type is equal to LLVM type struct type, no, struct type. What's this struct layout? Uses a LLVM data layout. We don't want struct layouts changing based on the computer we're compiling on, so I think I'm going to keep using my thing here. So if struct context packed, we want to def pack members. Otherwise, I think it's packed by default, but I'm gonna call the function just to be sure. Because I don't want to have to set it to packed to work. Maybe I can just manually define a data layout and pass it to this struct. If we have data layouts work differently on different devices, that actually might be good. If it just like gets JIT compiled differently. I'm not actually exporting structs to use them yet, so it should be fine for now. Yeah, nope. And we'll push back get LLVM type. For struct context. For M. Type. Actually, what's this a unique pointer to? Labeled value context. So type. Is that a value context? Actually, can I pass this in? Do I inherit? I do inherit. Okay. This is inherited class. So we can just pass it in like that. We get all the LLVM types. And then finally, we create this. We pass in. So yeah. LLVM context, LLVM types, and then finally is packed is set to struct context packed. Okay, that is a Boolean vector. LLVM array ref. Does that work? Huh. Okay, let's try this one instead. LLVM struct type, since we can. And let's call the override of this that takes a name. There we go. Okay, so entry, we also want And we should be able to use the LLVM struct type as context. But I don't really want to. Because I want the alignment of structs to be consistent across different devices. That way, if we send it over the network, for instance, we can just decompile it using the same definition. Okay, for now I'm going to set is exported to just see if we have a library context as a parent. So yeah, get LLVM type. We'll just pull a if we won't worry about it. We'll just say get def for value context type struct context. Okay, yeah. This function shouldn't be constant. So we'll just get def, make sure that we have actually, generated all this if we haven't yet. And then define structs at value context type identifier. Actually, let's have this return a reference to the entry. Not the entry that has been moved, though. Dang it, I would still have to do a key lookup for that. We'll keep it at def. So it doesn't really save us anything. We'll still have to do this lookup regardless. So we'll just return this LLVM type. All right. So we now have a way to generate the LLVM struct definitions, which are actually going to show up in the bytecode now. No, I should see if I can just use the LLVM thing instead of the struct defs, and then I can pass an array of the exported names. And then it can just... Actually, no, I wouldn't be able to do that because structure types are combined. Yeah, sometimes structure types are just discarded by LLVM's optimization processes. So we will have to manually export them ourselves as well. So unfortunately, that's not something we're able to just use LLVM for everything. We don't need to use it for everything. All right, there we go. Laziness abated. We actually use this. Okay, so we can get element types and get the type at index, which is exactly the same thing. Oh, get type at index and its value as the... That's really interesting. There's not a way to get offsets. So how do you access LLVM members? Because how do I get the... I need to know how to get the offset. So this guy's using a union, so this stuff is super weird. Okay, so he's jetting this code as well. Oh, it's used, you use get element pointer. Get element pointer instruction. Does it really? Oh joy. You create a get element pointer instruction using the create method. Is it a static function of the yeah? See, I get element pointer. They don't actually show the. So we just have to use the create method. Which namespace is it in? LLVM IR instructions. And this is a okay, it's struct type create. Oh, that's creating a structure. Get element pointer instance. Oh, it's in the global namespace? Just LLVM get pointer instance? Element pointer instance. That is weird. Well, it means I can throw this directly into the, I literally have a context for grabbing members, so. That's nice. I'll just keep that tabbed then. But yeah, let's move on to... We don't actually need to walk through every single global now, since they'll be created on demand by actually walking the tree. Structures, functions. So we literally just walk the function context in call order, and only create the globals that we actually use, though, in this case. Which means exports might get a bit... I'll worry about it later. That's... Actually, no. Do I need to... I'm not... It's structures I'm creating on command, not globals. So we still need to walk all the globals. Get or instant... Ah, this is why I was... Okay. Get LLVM type. Do I have 3 M? I do. I have 3 L's in there. There we go. That's better. G. Value context. Oh. G dot get. And just like that. And then do I want to... Okay, I have to define it anyway, so I'm going to define it here. So for auto live in exports. Get rinse. How do I refer to globals from other modules, though? Like an extern global. It might be this, in the bytecode, like this weak global. Where is it? let's combine these two. So I actually have 3 windows that I want. There we go. So in the bytecode, not bytecode, intermediate representation, I saw which one was it? Not this one. There it is. Weak global. So maybe this weak means only redefine this if it's not defined somewhere else. Because are these constants? I think these are supposed to be constants. And since they're constants, you want these to combine with any other globals of the same type. So after optimizing, these might combine. I'm not sure. They look exactly the same to me. Because we don't even define globals. This tutorial doesn't even define globals. So these can only be constants. Weak global, and then it should be a Boolean because all memory accesses are explicit with load store. It's carefully designed not to have or need an address if operator knows how. Even though the variable name is defined as 32, which means that this defines space for 32 int in the global data area, but its name actually refers to address. That's okay. So this is giving an example of globals without actually showing how to use them in the future. I'm just gonna guess that's what's going on there. 'Cause I have no idea. So instead of that, we're just gonna say lib. If we can actually spell it. Second dot. Create AST. And then let's actually go there. Actually, library is defined right above script, since they're basically the same thing. Ooh, joy! I have to define one for this, don't I? Cringe. That should never be called. Actually, on import context, maybe we do. For now, we don't want it ever called. For library set, we want this called. Never called as well. We might in the future, but not yet. we're not actually importing globals from other scripts yet, and I might just decree you may only use function definitions. Actually, I could just look this up. LLVM extern global variable. New goal thing. Okay, it's this linkage here. Interesting. Script context. Get or insert global. Oh, that's what the callback is for. I understand now. So in here, so we have a function ref. Can function ref take non-static functions? That's the question. Well, not unstatic. Can it take capturing lambdas or standard functions? That's my question. This class does not own the callable. It stores a reference to it. Oh, right. Well, let's just try this out here. And let's by reference. Okay. So this does work. So I'm going to create another function here. And make extern global variable as well. So this is what we'll use for local global variables, and this is what we'll use for external global variables. Oh joy, it's not liking this. I don't want to manually define the functions, but I will do what I must. And then from this, we'll actually return a lambda. This and a reference to value context. Return new LLVM global variable. And let's just reference this. And then for the type, actually, I can do better than this. I can just say get LLVM type for value context. We can do this inside the callback. Yes, I know. So you need to pass in the module, the type, yeah, I'm gonna manually define the return type just so that it stops complaining and we actually get type checking and whatnot. There we go. Type LLVM global variable Actually, what's the difference between external and external weak linkage? Rename collisions when linking. Okay, so this is what we want for private ones. Oh. So this is an externally visible. But omit from symbol table. This is probably what I'm going to do. We'll stick with the internal for now. External weak linkage description. Very good description. Love it. 10 out of 10. What does weak linkage mean? It's the same merging semantics as research as link once linkage, except that unreferenced globals with weak linkage may not be discarded. It might be more general than LLVM. Let's... Nope. Okay, Stack Overflow. When you have a vector, it's very handy to use to get default handlers for interrupts you're not interested in. Okay, we're not going to worry about this for now. We're just going to stick between external and internal linkage. We're just going to say external linkage. Actually, we need one for available externally. Externally visible. So I think yeah. And then when we make global variables for our internal program, we want to be able to set if this is public. So if it's actually we're going to go with is exported since that's a defined thing. So it should export, usually false. And then finally the name, value context, long ID. Oh. Is constant. I think we want this one. So we'll throw is constant into there as well. There we go. And we can add that later. All right. Private linkage. Available externally linkage. Ah. We'll make this a little bit cleaner. That is disgusting. Why are you doing it like that? I hate the one-line offset stuff. We'll stick with it for now. But yeah, now we have a way to define what type of global we want. So back in document context. Do I not link the library set in the import context? I'm not too worried about external globals at the moment. For now, people can just use external functions to handle the same thing, I think. Oh, what the hell. Where is ST context? Script context. I will just call this base node and set it to null pointer. And then when scripts enter here, we'll set context base node is equal to this. And that way, we need to do stuff like get parent and whatnot. We can check if stuff is a child of the thing. So one thing I need to do is in the static analyzer, actually back here first. In here, we do actually need to reference yeah, we'll call it modules for now. And that's going to make library sets almost unneeded if I just do that. Okay, so here in the static analyzer, visit import okay, visit link. I change the name of this so often. So since multiple scripts or modules can add to a library namespace, this is actually a set of different libraries. So if not libraries, otherwise libraries. Why would it be empty? Oh, we're okay. We don't need to assert if alias exists. This is like the first thing where I had errors in using this for the VS Code plugin, and I had issues where these pointers were null, and my way to handle it was just if statements instead of these assert statements. So yeah, if not libraries, else we want to see if auto local lib no script context exports dot find i.library. Basically, we don't want to include local definitions of library in what is supposed to be the links to external libraries. So if local lib is not equal to this dot end, then let's say this is iter. Equals null pointer local lib. Imported modules. You have to do it either way. So local lib is equal to local lib iter. Second dot get. So for auto import in libraries. If import. Oh, I don't have a subscript or iterator. I think we just got to the end of my playlist. Oh no, it has 2 songs left. Even still, let's move on to a new one. Let's go more cyberpunk this time. Libraries, exports. This is an unordered set. If import is not equal to local lib, I dot imported modules. Let's pull a reserve here. For libraries exports dot size minus local lib iterator. If this is 1, otherwise 0. Just local lib. So if this is defined, subtract size by 1 because we're not going to be including one of the results. Otherwise, just have this be 0. No, I don't want to push back local lib. We want to push back import. It's about to be an array of only the things I don't want to add. And all these errors are just because it doesn't want to create things. All right, anyway. Back in document context. In this .createAST, we no longer assert false. Instead, And then in here, we're going to do that get or insert global. Make global variable G false. And then back over here, we're going to do the same thing, but this time make extern oh, because it's a there we go. Alrighty. What is argpack instance? I think that's for templates, so we're just not ever going to use it in the AST. It's more of a thing to pass around. Actually, where am I using that? Yeah, an argument pack. Oh wait, this is deep copy. So it's used within itself. We pass it into construct argument list. Oh, yep. We use this in templates and only templates. And there's not really a reason for it to be a document context. I don't think. I'm not gonna risk that refactor right now, but where is error? Oh, it's because it is an abstract class. Okay, fine. We will give it a assert false AST. No, you could at least be nice and actually generate the function for me. Oh, I'll be right back.
to do this.
Throw some shiny materials on it.
I'm just gonna chrome. It's time to chrome the fuck up.
Oh yeah. I'm gonna go get back to my stream. I'm making good progress. It turns out LLVM is really easy to use if you know how compilers work. Yeah, good luck. Oh, thank you. Have returned. So if you hear a little bit of music overlap, that's because I'm watching my roommate stream. He's currently working on a render of a gun. But yeah. Where was I? Ah, yes. Create AST. And that error is gone now. Okay. Import context, create AST, global variable. And that just creates external global variables for all of the external scripts. Alrighty. So let's actually iterate over those. So each library we will create an AST, and that will insert all of the external global variables we might ever need to link to. All right, let's do library context next. Copy the function def. Library context. Hey, it actually worked this time. Should export true. All right, and we don't visit functions there because we want to visit functions here in order. In call order. Create AST context. And of course I haven't defined it there yet, so now we get to create the AST of a function. So now when we create the AST for a function, this is where it starts getting spicy. Because we actually need to start generating code here. So basically, first we need to create a function signature, like so. Let's get an array of argument types. So for auto reference arg in arguments, yes. Arg types push back. And we reserve arguments size. And context, get LLVM type, arg. Oh? Labeled value context. Oh. I keep thinking reference, it's actually pointer. Archetypes. Context, LLVM context. Actually, we don't want this. We want context dot get LLVM type, and then return type. Like so. Okay, what do we do for functions that don't return anything? Does LLVM actually have a void type? LLVM type void? Oh. There is a void type. So we actually do need get LLVM type to have a case for void. Case value type void, return LLVM type get void type. So now that we have function sig, we actually need to create the function. Ooh, do I need to store references to this? If get parent library context, then we do want to do external linkage. Otherwise, we want to do LLVM function in private linkage. So this is our function. And then I think this just gets added to the module automatically, so I don't actually need to store references to it. Yeah, because we can just search the module for it. We'll see. When we get to function calls, we will see if we need to store this anywhere or if we can just search the module for it. We don't want it to only be named a test function though. We want to change this to long ID, like that. It attaches it to a module, places the function in the program, address space specified by the module's data layout. Okay. So I may have to refactor this quite a bit later, because I know basic blocks are for every section of code with no branching whatsoever. So oh, looks like we're getting a moment of truth. So this is a gun that he's making for one of the games we want to make once the engine I'm working on is actually ready. Oh, it's looking good. It looked like he had a rendered thing and he was changing it to a GIF. There we go. We get the render. Indeed, spinning gun. All right. And to get back to what we were doing, which is talking about this. So there's a basic block for every section of code that occurs without branching. I think what I'm going to do for now is just create a pointer here to block. So when anything branches, they can just change the block. Okay, since we need to set the parent of the block, is the parent always a function though? Can we say it without the... Okay, so we have to give it a name. So it has to be... yeah. Okay. I'm just wondering if I can abstract this away into context. So it's just context.new block. Well, since the parent is always a function, I can always just say context current function. I might have to implement like a stack of functions in the future for like when we start creating lambdas, but that's going to be a super easy change. So in context, we're going to just create a function called new block. In here. Oh, hey, thanks for the raid. Very much appreciate it. For those coming in, what we're working on is converting my current scripting language backend to one run by LLVM. So I already have a working scripting language, but right now we're working on moving it over to, well, a more established and less likely to break library. Yep. Hey, how you doing? So we're going to copy this into context new block. Nice. Bug fixes are always the best. I am. Luckily, LLVM is a lot easier to use than I was scared that it was. But it turns out it's pretty easy when you know how compilers work. Which, given that I've spent the last 6 months building one from scratch, using a library is a lot easier than writing it from scratch. Okay. It's not a constant reference. Oh, it's saying use it as a constant reference. Whatever. I'm gonna put the standard move there and you can't do anything about it. So you said you're doing, oh, Quantum. I didn't realize it was you. You get much done. Let's see, it was I am GUI, right? Nice. See, so what was I gonna do? Oh, right. What we need to do is... There you go. Shifting over that tab made me unable to read my own code. We need to extract the function arguments. And throw them into the... Yeah. And for some reason, they don't actually give you an indexing operator, so you have to use the ranged for each. So we're going to have an index here. And we actually need to add a scoping into the AST context, just so that we don't have to manually manage this. So we're going to say void push scope and pop scope as well. Then finally, we're going to pull a find value as well that will manually iterate through the list of scopes and see if the value is defined. So let's do this one by one. So I am currently in the process of building a game engine as well. So the idea is that the scripting language would be used inside of that. And the reason that I am making my own scripting language instead of using an existing one is I couldn't really find any scripting language solution that fit what I wanted, because since my game engine is using an entity component system, it doesn't need heavy uses of classes or anything. So I didn't really want to include the entire mono C# runtime in my project, because I felt like it was a lot more bloat than I needed. But I didn't want to go with Lua or LuaJIT, just because I am not a fan of dynamic typing. And also, I did a speed comparison between, this was after I decided to build my own language, because I had my own language to test, but I tested the speed of the old version of this language not using using a different backend. So I had a JIT library. Where are you? Yeah, so I just like used a JIT library to make assembly language code at runtime. So that's the way it worked before. We are now uh, porting it over to LLVM, and LLVM has its own JIT solution. Anyway, I tested LuaJIT versus the JIT compiled thing that I had made in like 3 months, and I was actually faster than LuaJIT. So I was like, uh, yeah, we're just gonna build our own, because I also want my engine to. It's eventually going to be a VR focused game engine, so performance is extremely important. So we're going to go with the well, with the custom language that is hopefully just as performant while we're using LLVM and not my jank bytecode. Yes, that is pretty much exactly what it's going to be. And the reason I'm jitting it instead of creating binaries and then, well, the normal way of doing scripting and whatnot, is because it's going to be what I'm calling an asset streaming game engine. So basically, you download the game as you play it, similar to how like web games and whatnot work, but I'm reinventing the entire web browser to use that to use that analogy. So that's one reason why I didn't go with LLVM before, because I wasn't sure if the bytecode was cross-platform, even though now upon doing more research I realized, oh, LLVM is like fully cross-platform. That's the entire point of LLVM. So yeah, the current plan is this over here. This is like my test of LLVM, so it has like all the steps, going through jitting a function and then actually calling it. And I also test out like the serialization of the bytecode and deserialization of the bytecode, like all of the steps for that. What do you mean by remote code execution? Do you mean like, will there be remote code execution vulnerabilities in it? Because that is something I'm thinking about right now. Like if I'm building my own like embedded scripting language, how secure is it going to be? How do I make sure people aren't like, completely abusing that? And I do have things in the background I'm working on to make sure that it can't do that. Like I do plan on creating, like, I'm not sure if you can embed system calls in LLVM bytecode yet, but I do plan on, if that is possible, we're going to scan the bytecode for that. Another thing, I might make it so that I don't allow native heap memory allocation in the bytecode. So like I'll scan it and see if there's like any calls to malloc or whatever, and just not load the script in that case. And then just have my own function that I link into the JIT runtime that it would call to do those things, so I could keep track of like memory allocation and whatnot. That's another idea I had for security. I might not need to end up doing that, because like obviously my concern there is like if a script would just allocate a ton of memory, we unload the script but the memory is all still there. I think the where is it? There's a resource tracker in here that kind of so the sandbox, and I'm going to be heavily sandboxing this. It runs inside the the execution session. So it's an LLVM module, and in the like documentation of the LLVM module itself, they do say it is possible to create a secure sandbox for things like this, because they know people are going to try to use it for that, so they put it right in there. But you do have to do some stuff like scan the bytecode for certain commands beforehand and whatnot. Yeah. Like, the only way that the scripting language is going to be able to interact with the engine is through a few API calls, and then mostly through calls to the actual ECS system itself. So hopefully that I'm gonna write it in this as secure a way I can as possible, so like you can't exploit the API and whatnot. It is something I'm thinking about like every step of the way. And the project is open source as well, so if somebody finds a vulnerability, hopefully they just put up an issue request instead of just exploiting that. Yeah, for sure. Layered approach is always best. Oh, is there like usually a GitHub bot? I might have it linked in my Twitch bio. Let's see. Channel. Do I have it here? Dang, I don't. Let me paste that in chat real fast for you. So I'll send you a link to the actual scripting language repository. So that's the scripting language, and obviously the engine is going to be, so the scripting language is Brane Script, the engine is Brane Engine. So yeah. All right, back to this. Scopes in place and scopes. So yes, this is going to be a module that I embed in. So the thing I'm working on right now is the actual compiling of the language, and that's only going to be embedded in the editor executable. However, the runtime itself, that will be in the server and the client. So, long answer, yes. So the Lua interpreter, but compiled down to machine code, and so it's like LuaJIT, but faster. And I am basing the language off of roughly C++ or a C-based language with a little bit of inspiration from C#. Minimum refresh rate. So the lowest modern headsets run at 72 hertz. I'm definitely going to want to aim for like 90 or 144 if that's possible, but 90 is about where you want to hit. Quests are 72 at the lowest. So that's kind of where I'm going to be aiming. Yeah, not 75, it's actually 72, so it's actually worse. So if let's do find value is equal to values dot find ID. All right, thanks for sticking around though. Yeah, I'm definitely looking forward to seeing, well, I can't really look forward because I don't know if anyone is, but I am building this with the hope that it's useful for other people as well. Just realized I turned this down, so it's probably really low. But yeah, I've had music going. Okay. All right, so we have that working. Where was I working before that? Oh, right. Let's create a helper function for add value as well. And we're gonna create a unnamed version of this as we don't want to create an unnamed version of this because we just return the unnamed values or lose the references to them. Stack dot scopes dot back dot insert value. And now we can use this in here. So for each one of these arguments, we want to context add a value. Well, before this, want to push the scope to actually contain these values in. And we want to do arguments index dot, well, not long ID, just identifier LLVM argument to value. Interesting. This is the same function, right? It's like begin, and that returns an iterator. And we're iterating through. But this is a different type for some reason. And we can get the value. Interesting. So this is literally the... It's literally the same iterator. Oh, wait. There we go. Alright. Now we're also going to... Apparently it's just a inherited class. And we also want to set the names as well. So that should take care of that at least. And now we want to if this function has a body, but you want to visit the body. And that calls the rest of the tree. It's never used. I'm literally calling it right there. That is the weirdest. It's editing an internal function though, so it's not. All right, on to the next thing. Which I guess is scope context. And let's grab this. Hello. How's it going? It is not generating function. Midwest and early 20s. All right. So this is a scope. It's a statement. Does not return any value. All right. So we have local variables, statements. Okay, so let's define these local variables. And we will need to call destructors, I believe. Actually, will I? Do I automatically call them, or do I add them into the... Is it struct... not struct. Scope. Okay, so I'm not adding a bunch of destruct context at the end of that. I probably should. It would be a smart idea. Because yeah, we have this labeled value construction context. So we automatically construct stuff right before, and that's part of the static analyzer. So let's do that as part of scope as well. If this is a structure, then we want to a new labeled value construction context, destruction context. Do I not have a destruction context? Was I just handling this in the compiler before? Okay, that's the one I was looking for. AOT value destruction. So I basically need to move all of this into the static analyzer, so it's all in one place. Since we're just going to completely delete these two files when we're done. AT value destruction. And this is just erroring out because it has a virtual function I haven't declared yet. It should be fine once we declare that. It's not helping me out. Let's see. And we can just pass in the AOT value. Oh, it's an ahead of time. Okay. I should have realized because the prefix I put on all of these, and it's my code. Let's create a destruction context because we are lacking one. It's basically just one of these, but with destruction. Want to change the identifier to be equal to value long ID and return type even though technically this isn't really going to return anything. Of course, the thing isn't working anymore. Come on, C-Line, you're such a good IDE. Why can't you just work? Right, while we're at it, so that works. Does this work now? Still doesn't. Alright. I guess we'll just implement this. This. That isn't working. Oh, there it is. Context, get find value. Okay, find value identifier. And we'll return value for good measure. We need to do a function call here to the constructor for this. Okay, if turn type struct context, then we want to do the struct context stuff, otherwise we just return the value immediately, because we don't really initialize non-struct values. People can do that manually. Okay. LLVM function call. I think what I want to do is context block call instance. All right, so this is like the signature of the function call. So we pass in the function type and the function. Shouldn't the function store the function type? Then again, we do have variable argument functions supported in LLVM, so maybe the function type just manually defines how many args. This is the arguments to the call. So we probably want to call one of these create functions. And where does this get inserted? Because wouldn't it be part of a basic block? Or does it count as a branch? It might count as its own branch, in which case we need to handle it differently. Let's see if control flow. Okay, so that's how you do if statements. Okay, so I do need to store function pointers somewhere where I can find them. Oh, so it's part of the builder. Okay. Okay. So we create call. And into there we're going to pass the function we want. So ast context. Unordered map. String LLVM function. And this is where we'll store linked functions as well. This is in instructions. It's not in instructions. I was just... Okay. So in create AST, Next, functions insert. Signature. Oh, I want to put signature there. Generate the function signature, and then we definitely don't want long ID because then we're gonna have clashes with function overrides. Actually, we do want long ID there because that's the name we're passing to LLVM to be the actual name. So it's in here that we want to insert the signature. Here's where we insert the function. And we'll have to do this for linked functions as well. Dang it. The amount of times I've had to write a function to create the signature for a constructor is absolutely insane. Let's actually get these. And in document context, I'm gonna go to struct context. And in here, we're gonna create we're not gonna do it like that. No, we might. We'll just use the definitions. It's like a template. Okay, and these won't take any arguments and they will be constant. I'm dumb. Why? Let's put you right there. Oh joy, we have to wait while the compiler, well, the analyzer catches up, or we just create the signatures ourselves. Here we go. For the move constructor, it's a little bit more complicated. With the copy, we should just be able to that. Same thing here, but with the copy constructor. And finally, the destructor. Just like that. There we go. I will never have to write these functions again. No matter what refactors I do. Unless I just completely delete document context nodes, which I've been tempted to do more than you might think. Alright, back to labeled value construction context. Up and there we go. So context functions find, return type, struct context, dot, constructor sig, assert function. Not equal to context. functions dot end. And here we need value ref. So context builder dot get. Okay. I remember I have tabs for this. So that's get element pointer is so that's for getting elements of a structure. LLVM get pointer to value. Create, okay. So we want to create struct GEP Is that what I want? Get element pointer, create struct get element, okay. Okay, I think what I want is create pointer cast. Pass in the value, the destination type, which is this casting from one type to another? Would the destination type just be the same type as the value because it's a pointer to... Just do a general search. What's this one again? Yeah, I know about get element pointer, but what's the actual API? Okay. Oh, do I need to create a new value for the pointer? Does this return anything? It does, but I think that's a pointer to the eventual, like the return value. Oh, that's deprecated, of course. Use the version with explicit element type instead. Index. That's the bytecode. Show me it with the API. Alright. Alright, we're... Let's see if ChatGPT knows the answer. It has no idea. Oh. No, I don't want the... It's the same problem I was having in search engines. Which, I mean, is to be expected because this is essentially a reflection of a search engine. That is a very vague prompt. I'm probably not going to get a great answer for that. Oh. It must just be under like super heavy load at the moment. So it creates a struct, and then we create an instruction, which is LLVM get element pointer instance. I mean, we can try it. Get element pointer instance. Create a get element pointer instruction with a base pointer, list of indices. Insert before an existing instruction. The second appends the new instruction to a... Okay, so we want to do this for a block. pointy type. And this is the thing we want to get a pointer to. What the value is. Is this for like if we want to Okay, so I can't do that. Okay. This is literally the indices of the struct. And then, I guess for the last value, lock. Okay, so if we pass in the value, then indexes, and then let's try it with this instead. What's this get element pointer supposed to be? The array. Yeah, I know all of that, but how do I... I just need one good documentation of what this function actually looks like. Here, I'm just gonna try with whatever that is. But if I'm just getting the pointer to the struct, I shouldn't need an array of values. Create load and create store. It's easy enough, but okay, I get how to make it in the bytecode. How do I emit the bytecode though? I'm not necessarily a prompt dev, it's more so I've gotten so desperate to try to find any documentation on this whatsoever that I resorted to asking ChatGPT for it. And even that's not real. It's. I mean, I'm guessing if I just copied and pasted it in, it would maybe work, but I don't understand. Yeah. I don't want the indices of the struct that I want to access. I just want to get a pointer to the base of the struct. Oh, maybe that's what I need. Type, pointer, index, and then name. Okay, LLVM, type, get. Okay, what was the thing? LLVM pointer type. Get. Value.getType, and then 0. Value 0, and then all right, I finally have it should not have been that hard. Okay, back to function call. Oh, there it is. Maybe. Nope. Oh, whatever, we'll just look at the route function. Okay, so just arguments and then the name of the function call. strings. And both of those have default. Are we talking about this one? Ah, that's the... This is like calling a function pointer here. This should just work. So function, functions, LLVM function. Wait a second. So function is an iterator. If we dereference that function iterator, we get another pointer. There we go. And after that, we finally have a call to the constructor. All right, let's do it for destruction context now. This still isn't working, dang it. After all of that, my IDE cannot catch up with me. Basically just copy this, but instead of constructor, we do destructor sig. Hey, thanks for the follow. I appreciate it. Greetings. Nice. Discord bots are always fun to build. Actually, is that a Discord bot? I haven't heard of however you pronounce that before. I'm not going to try to pronounce that. It's far too late. Oh, okay, so it's a Plex. Is it a way to like stream it to Discord calls or something like that? Okay, that makes sense. Okay, so just Tatuli. Okay. Easy enough. I can barely pronounce English sometimes, so anytime there's... I mean, it is not necessarily a foreign language, but... Dyslexia of the mouth. Hey, how's it going? right. Theoretically, that works. Right, to function call context. Oh joy. Here's where I deal with the consequences of my own actions. And that is, I am. So right now I'm working on a scripting language for use in the game engine that I'm currently working on. It's like a mix between C and C sharp. That's probably the closest point. So it's like C style syntax, but with C sharp references. So no direct memory management. The idea is that since my game engine is entity component system based, the scripting language doesn't need to actually store that much data or create pointers. It's just getting references, which are pointers behind the scenes, from the entity component system, and then just doing transformations on those rather than actually needing to create anything itself. So type creation inside the languages is rather limited, mostly constrained to the stack and whatnot, if that made any sense whatsoever. I mean, you could say it's hard, but for me right now, this is feeling a lot easier because for the past 6 months, I was writing it just from scratch, and now I've switched to actually using a LLVM, which is pretty much the way to make coding languages. It's a modular toolkit for actually building compilers. Before I was writing everything from scratch with like a very bare bones JIT library for the actual runtime. So this by comparison is a lot easier. So if our input type is a pointer, can we just use the same code? Might be able to. I'm gonna go with yes, it's this easy. So I have 2 identical branches. I'm keeping this one just in case I need to refactor it later. The reason why I'm so hesitant to create the function call context is because every single operator, even native ones like you know, casting and adding of basic types, when I parse it out, I convert it to just a function call of the operator. To just kind of show what that looks like, if we... So yeah, every single one of these is like just a regular assembly code instruction most of the time, but I converted them all to function calls instead of different node types in the tree. So what I'm probably going to do is refactor document context to have a separate node type for casts, and then like native versions of these. And then when we're actually parsing the grammar, we detect, hey, is this a native operation, or is it an actual like function call that's been overridden, because I support both. But it's 2:30, so I'm probably going to end the stream here because I do have work in the morning. But yeah, thank you to those who are watching. I'm going to end it there. But yeah, thanks for watching. I will see you next time. I'll probably stream again like tomorrow or the day after. But yeah.